So let's begin the session of this like some basic concepts of chemistry from very basic. Okay, so we know when we are discussing about chemistry or chemical substances. Okay, so what we need to know is first matter. So what exactly matter means? So yeah, any substance, that is anything that has some mass and occupies some space, we are saying it as matter. So chemical substance, all chemical substances comes under matter. Okay, so that's why I am starting with the term called matter. So matter means, matter is anything that occupies space, possesses some mass and offers some resistance that can be felt by one or more of our senses. Okay, something like water, okay, we can able to touch it right now. Yeah, so air, yeah, so the next metals, non-metals, all these are comes under what? Matter. Okay, so now if I say oxygen gas, it's a matter only now, like this, anything. Okay, so now here matter classification, how can we classify this matter? So matter can be classified based on their physical classification and based on their chemical nature, or I can say chemical classification. Okay, so here physical classification means what I can say, it can be in based on the physical states. So I can say it can be in solid, liquid, or it can be gas phase, right now. Now chemical classification means some compounds, some matter may be in pure state right now and some can be impure form. Okay, like mixture of two compounds, if I am saying, is it pure or impure? Impure. Mixture I am saying, so I can say it is impure. So I can say chemical classification as pure substance and impure. Sometimes it is also mentioned as mixture here. Mixture. Okay, so now again this pure substance can be classified as, like tell me some pure like substance if I ask. So this can be elements. So what do we mean by element? Yeah, this is a natural existence of a particular atom. For example, carbon atom we are saying. So what is the I can say the carbon atom has its own individual properties, right? So nitrogen atom I am saying, okay, it has its own individual properties when we compare with this carbon. So now that carbon, I can say it is an example of element, nitrogen again example of element. Like that we also have something called compounds. Okay, so something like we are saying water is a compound or not? Yes, so this water is composed of what? Composed of what? Elements, like atoms. Like water example if I say, it contains what? Hydrogen atoms and oxygen atoms, but they have fixed ratio. Like I will tell you what is this fixed ratio. See, 2 hydrogen atoms and 1 oxygen atom is there now. So it has fixed ratio. We will discuss about that in law of conservation of mass and all those things. So now water has fixed composition of hydrogen and oxygen right now. Okay, so now you should not say this is a mixture. It is what? Compound is like water is a pure compound. Now to the water if I add any external things, something like salt I am adding, now it becomes what? Mixture, it becomes impure, it will become right now. So water is a pure compound and like anything you can take. Sugar, if I say sugar, is it pure or impure? Sugar, it's a compound now, it means it is a pure substance. Okay, so now these mixtures are also again 2 types. How many types I told? 2 types. So what are those? Homogeneous and heterogeneous. Okay, like this. Okay, so now here give some examples of elements. So in periodic table how many elements are there as of now? We have 118 elements. So therefore, these 118 elements includes metals, non-metals, metalloids. So I should write here elements again classified as metals, metalloids and non-metals. Okay, and here, yeah, so tell me about metals, give some examples of metals like sodium metal, alkali metal, alkaline earth metals we are saying now. So all those comes under here, and copper, silver, all these are examples like etc. I am writing here. Okay, so here metalloids are like something like phosphorus, arsenic, antimony, bismuth, all these are examples of metalloids. Okay, silicon, all these are examples of metalloids. Okay, next what about non-metals? Like hydrogen gas you are saying, next oxygen gas, fluorine gas, halogens, I mean next inert gases, all this comes under what? Non-metals. Okay, so now metals are having electropositive nature. What is that electropositive nature? It means in chemistry, remember, any element if it is losing electron, electron has a charge of negative, -1. If in chemistry, if any element loses electron, that respective ion generating from should have positive charge like this. So it is losing one electron now like this. Okay, so -1 + 1 overall 0. So atom has 0 charge, but respective cations like positive charge is there means you should say cation. Okay, so now by losing one electron it is becoming cation of that respective atom. Okay, so now metals have electropositive nature. It means what? Metals have tendency to lose the electrons. By losing electron they will become respective cation. So for example, if you see all the cases, sodium atom whenever it is combined with other elements like sodium atom I am taking, whenever it react with any species, what it will become? It will become Na plus and releases that electron. So this electron will be taking part in the chemical reaction. Now it will be always in +1 charge. Sodium will be always with a unipositive +1 charge. Is that clear? Okay. So now if I say alkali metals, these are what? Alkali metals. Okay. Similar to these, sodium you can take, lithium you can take, all these are with what state? +1 oxidation state. Okay. So these are highly reactive. What do we mean by highly reactive here? They will easily give its electron whenever it exposed to anything. For example, if you throw a pinch of sodium in water, so you will see a exothermic reaction there. Why exothermic reaction? Yeah, so whenever you throw that electron, that like this element, so it will releases its electron very readily, that is taken by water molecule and releases hydrogen gas with some fire, like exothermic reaction we should say. Okay, so I hope you got some clarity what happens in case of metals. They will easily releases electron. So more tendency to release electron, more is its metallic nature. Okay, so now when I compare sodium with this copper, okay, so which is having more metallic nature, if I ask, your answer should be sodium. Why? Because it has very high tendency to release the electrons. So more the tendency to release the electrons, more is a positive character, more is a positive character, more is its metallic nature. Is that clear what I am saying? Yes, yes, yes. Okay, then next, here we have metalloids. Metalloids have intermediate properties between metals, non-metals. Okay, so now what are the properties of non-metals then? So they have properties, a tendency to gain the electron. For example, here I am saying fluorine is an example I am taking here. So what is its electronic configuration? You know basic idea on electronic configuration. What is the atomic number of fluorine? 9. Okay, so 9. 10th element is what? Neon. What is that? Neon. By giving one more electron to this fluorine, it will get a neon gas configuration right now. So that's why neon gas, why I am talking about neon gas, those are the 18th group element. Noble gases we are saying, inert gases we are saying, those are stable gases. Okay, so all the other elements in the periodic table always tends to attain this inert gas, noble gas configuration by either losing the electron or by gaining the electron. See this fellow here, sodium, all alkali metals losing their electron. Why? If they release the electron, sodium atomic number is 11. By releasing that electron, it becomes how many electrons? Atomic number will be 11 only, but it will be having how many electrons now? 10 electrons only, right now, by releasing 1 electron, right now. So it means this 10 electrons means it is stable electronic configuration, neon. Okay, similar to this, now fluorine has 9 electrons in it. It means what is its electronic configuration? 1s2, 2s2, 2p, 2p, 5 for fluorine. Like you are saying 1s2, 2s2. So 2 plus 2, 4 plus 5, 9 now. So its atomic number is 9. Now by giving one more electron to it, see p orbital you should write like 3 orbitals, means you put 3 boxes like this. So 5 electrons now, each orbital should have one with same spin first. After that second electron should be having opposite spin like this. Now how many electrons are over? 5. One more electron should be, if we give, that can be accommodated here. Therefore all the orbitals will be fulfilled. So therefore fluorine has high tendency to take the electron, gain the electron, right now. So now generally non-metals have more tendency to gain the electron, whereas metals have tendency to lose the electron. Okay, so now what I can say, when a metal is there and when a non-metal is there, something like fluorine, chlorine and all, so what they will do, these fellows will release the electron and this will gain that electron and become respective anion like this. Okay, so when a metal and a non-metal is fixed, so when they combine, we are going to get a ionic compound. What we are going to get? Because what I told you, these metals, like especially if I talk about alkali metal, they have tendency to release the electron. So that really after releasing it is forming cation. Now that is taken by fluorine and forms a fluoride ion. This is fluoride ion. So two oppositely charged ions are there now. So opposite charges means they will come close to each other. So that is what we are getting a resultant compound as ionic compound, because compound formed from the respective ions. Is that clear or not? Yes. Okay. Now here give some examples of compounds. Compounds can be, again I can say organic and inorganic. Okay. So these are organic compounds and inorganic compounds. So generally if I want to test say this about these organic compounds, generally those are made up of what? Carbon. Okay, it means actually why the word organic is used here, you should get this down. At the beginning, initially when scientists were discovering elements or compounds, okay, so they consider that those compounds which originate from natural sources, from living plants, living beings, plants, like this, from some like life existence is there now, plants, animals. So if we consider any compound from this like living things, those are comes under organic, and those which are comes from non-living things, something like minerals I am saying, like from earth crust we are extracting them, so those comes under inorganic. Are you clear with this? Okay, so that is what considered, and they told that organic compounds cannot be synthesized in the lab synthetically, they only exist from natural, I mean living things. But later on what happens, as experiments went on, sometimes scientists were discovered some organic compounds in the lab. The first organic compound synthesized is urea, that is synthesized within the lab by so after that what it is told, so organic compounds not only exist from living things, that can be also synthesized from the lab also. Okay, but the word is remains same. Okay, so most of the organic compounds, all the organic compounds I can say, contains what? Carbon as one of the major constituent. Okay, so carbon and its compounds, like carbon containing compounds comes under the examples of this organic compounds. Give some examples, like carbon and hydrogen, like all hydrocarbons, like you are saying the methane, ethane, all these things. okay, comes under what? Organic compounds. Okay, and next anything like you can say formaldehyde, all these are comes under like acetic acid I am saying, many things, benzene, all this comes under what? Organic compounds. Okay, so now what about, you know, you will eat like you know na, vanilla ice cream. So now tell me what is it? Organic compound or inorganic compound? It is also organic compound. Okay, so vanilla, see that can be extracted from vanilla tree now, vanillin tree, like tree will be there, plant will be there, it's a flavor, right? That will be extracted from that vanilla plants. Okay, so it means which comes under what? Organic. Okay, so that is also comes under organic. Is that clear? So now I am extracting something like minerals, ores, minerals. For example, bauxite, all these ores are there now. For example, I am extracting some metals from earth crust. So that comes under what? Inorganic. Okay, like aluminium, all this, like examples I am saying silicates, like sulfates, all this comes under what? Like metal sulfates, metal silicates, these are comes under what? Inorganic compounds. Is that clear? Some basic idea you got what exactly organic, inorganic compounds here are. Okay, so these are extracted from non-living things, you can consider. Okay, yeah. So now here homogeneous, heterogeneous. So compounds that should contain single phase. See for example, overall like whatever the mixture I am taking, if that mixture, for example, I am having water. Water has what state? What is the physical state? Liquid now at room temperature. So to this I am adding sodium chloride. What happens? Sodium chloride, some amount of sodium chloride I am adding. What happens? This complete NaCl will dissolve right now. So therefore we are going to get a single phase. That is also appears in liquid state only now. So that comes under what? Homogeneous. So I can say salt solution, NaCl solution comes under homogeneous example, homogeneous mixture. Okay, it should contain one phase or single phase for homogeneous. For heterogeneous, more than one phase. For example, mixture of sand with water, what happens? Sand in water. So water will be having liquid, but this sand won't dissolve here now, this will be in solid state. Having two different phases now, solid phase, liquid phase. So this comes under what? Heterogeneous mixtures. Is that clear everything? Everything is clear now here? Any doubts are there? No doubts. Okay? Yes. Yeah. Let us continue with few more discussions here. Yeah. So we discussed about different classification of physical classification, chemical classification. Okay. Next, pure and impure substances also done. Yeah. Then next, elements, metals, non-metals, metal ions also done. Yeah. Compounds, organic and inorganic. See, elements other than carbon here. If carbon is carbon is an essential element of organic compound. Okay. So they are generally how biological source of energy. So for example, oils, fats, these are biological essence only now, origins only now. Next, inorganic. See, these compounds contains generally elements other than carbon are also part of these compounds. Okay, generally non-living are the source like NaCl, marble where we can extract from earth crust. Okay, from non-living source. Okay, next. So tell me answer for these questions. The purest form of a substance among the following is? Element is a purest form. Okay, whereas solution, mixture both comes under like having at least two or more components in it. Right now? Okay. Next, what about this? So the following is are non-metals. Very easy? Yes, tell me. So the following is are non-metals. Okay, nitrogen, very easy. And next, any other? Carbon. Okay, that's it. Okay, yeah. Next, here, metalloid. Which of the following is metalloid? Tell me. Metalloid. In the examples I have written one of the element. Silicon, bromine is a non-metal. Okay, iron is also it's a metal. Okay, copper is also it's a metal. Iron is also copper is also metal. Okay, this is non-metal, this is metalloid. So your answer should be 1. Very basic, right? Okay, yes. Next. Okay, so what are the properties we can expect for matter? See, properties of matter is classified into 2 things. One is physical property, another one is chemical property. Physical properties means what? Like something like its mass, density. Without changing its composition, we are just measuring. See here, physical properties are those properties that can be measured or observed without changing its identity. Okay, so for example, color of a substance. If I say color of sodium chloride or color of salt. What is the color of salt? Sodium chloride. Table salt is there now in your home. So what is the color? White color, right now. So without changing its physical, like any of its identity, by just by looking at it, you are saying its color. So that comes under, color is a physical property. Like that, its hardness. Next, rigidity, fluidity, density, melting point, boiling points. These comes under what?
Physical properties.
See, melting point, boiling points also physical properties only. See, you just heat that, but you are not changing its chemical composition. Right now, chemical composition remains the same. That just convert some solid state to liquid state or liquid state to gaseous state, like this. Okay, if I ask melting point, solid to liquid. Okay, boiling point, liquid to gas. Here just they are changing their physical states, but composition of that particular compound will remains same. So those are considered as physical properties. Hope it is also clear. Yes, let us okay, give me some time. Try this question. Okay, let me. Yeah, this is clear now. Yeah, next. So now, in order to express how much quantity of a particular matter we have, we need some physical quantities. Like for example, I have salt, I am saying, but how much quantity it is? That is expressed in terms of mass, like 1 kg of salt, half kg of salt we are saying now. So some physical quantities and their SI base units. So what are the physical quantities? In order to measure how much like long it is, we are using length. Units is meter. Okay, and symbol is m. So mass, to express amount of substance we have, so that will be kg, kilogram. Okay, kg here. Okay, so now time, seconds, S, temperature in Kelvin. Okay, K. Next, volume, cubic meter, meter cube. Okay, density, kilogram per cubic meter, means kg per meter cube. Okay, next, pressure, pascals, PA. Okay, yeah. Next. So measurement of volume, pressure and temperature. How we are going to measure volume? Okay, so generally volume means what? Generally in mathematics you will study now. Volume means something like length into breadth into height. So I can say length can be meter, breadth is also length, I mean in terms of length only now. I mean in terms of like meters only now. So height is also in terms of meter. All these are in terms of meter. So I can say meter cube. Okay, yeah. So we can get meter cube. So now if I want to convert into centimeters, so 1 meter will be 100 centimeters. Okay, so I can say 1 meter 100 centimeter. So by 100 centimeter. Now volume is something like a 3-dimensional thing. Okay, so volume, like water bottle we have. We are saying 1 liter bottle, like 1 liter bottle, half liter bottle, like that, right now. Okay, so now if I say 1 liter of any solution, if I take, okay, so that 1 liter of solution, 1 ml of any solution, if I say, that 1 ml of solution will fits in 1 centimeter cube of volume. So I can say 1 ml is equals to centimeter cube. So from this, what I am going to get? This is a basic one. So from this, I am going to get relation between what? Liter and meter cube. Something like this. 1 liter equals to 10 power 3 centimeter cube I am writing. How I am going to write this? See, milli means what? M means nothing but milli means what? 10 power minus 3 liter. Okay. And centi means what? 10 power minus 2 meters. Centi means what? 10 power minus 2. Milli means 10 power minus 3. Okay. So all to the power what we have here? 3 we have. So I can write this as 10 power minus 6 meter cube here. Right now. And this side 10 power minus 3 liters. Okay. So this minus 3 here 10 power minus 6 we have. So I can write remaining 3. So 1 liter is, how can I write? 1 liter is equals to 10 power minus 3 meter cube. Okay. Like this I can link to the any of the things. Okay. Now I can convert this into centimeters, so that we are going to end up with this kind of relations. 1 liter equals to 10 power 3 centimeter cube or 10 power 3 ml. Okay. Or this will be also decimeter cube. Like this we are going to get something like this. See, 1 liter equals 10 power minus 3 meter cube. Do we got here or not? Yeah. So like this. Okay. But what is the basic thing you should remember? 1 ml equals to 1 centimeter cube. Okay. Next. Here pressure. The units of pressure will be like in terms of atmospheric pressure. 1 atm I can say. So 1 atm is nothing but 76 centimeter or 760 mm of Hg. So what is this mm of Hg? So in the instrument, when we are measuring pressure, when we have 1 atm of pressure, the mercury in that instrument will rise to 76 centimeters or 760 mm of Hg, the height of mercury I can say. Okay, that is also mm of Hg is also said as torr, 760 torrs I can say. Okay, so yeah, these are the very important things you can remember, or lbs also you can remember. Next, so this pressure like 1 atm is also equals to 1.01325 bar. Okay, so these things are also very important. So now what is the relation between 1 atm and 1 bar? 1 atm equals to 1.0125 bar, or I can say 1 bar equals to 0.987 atm. So these units are also important whenever it is using in the numericals. These are very useful. So 1 Pascal, or also we can express a pressure in terms of pascals. 1 Pascal is nothing but 1 Newton per meter square. Next, temperature. So for temperature we have Celsius scale, Kelvin scale and Fahrenheit scale. 3 scales are there. Okay. So now if any temperature is mentioned in degrees Celsius, how can you convert into kelvins? So temperature in Kelvin will be equals to, see, we have scales I am saying now. So when I say 0 degrees Celsius, that will be equivalent to 273 Kelvin, 273.15 Kelvin on Kelvin scale. So 0 degrees equivalent to what? 273.15 Kelvin. Okay. So now I am saying 25 or 27 degrees Celsius I am giving. So how many kelvins it will be? Is that question is clear? I am giving temperature as 27 degrees Celsius. How can you express that in Kelvin scale, temperature in Kelvin scale? What we should do? See, 0 degrees means 273. Now I am saying 27 degrees means how many kelvins? See, 0 means 273. So instead of writing here 0, I can write 273.15 plus whatever the value I am going to give you. So that will be temperature in degrees Celsius. So it will be 273 plus 27. So what is your answer here? 300 Kelvin. Like 0.5, I just remove this 0.15 just for simplification. Okay, so this will be your answer. So if I give 27 degrees Celsius, what is your answer? 300 Kelvin. If I am going to give you 37 degrees Celsius, how much it is? See, if it is 27, it is 300. Now just add 273 plus 37. 310. How much? 310 Kelvin. Is that clear? Is that clear or not? Yeah. This is very basic thing. Okay. And next, we have one more scale I am saying now. We have related these two scales. Now I just want to relate Celsius scale and Fahrenheit scale. So on Celsius scale, if I say 0 degrees, this is equivalent to 32 degrees, 32 Fahrenheit. Okay. So now we are talking about what? Temperature in Celsius and Fahrenheit. No? So temperature in Fahrenheit, okay, and here temperature in Fahrenheit. Okay. So what I am going to make is, I just wanted to make a formula for this. See, these are equivalent. Okay. So here on Celsius scale, if I say 100 degrees, so on Fahrenheit scale it will be 212 Fahrenheit. Okay. If I say here 0 degrees, what you told here, it will be 32. Did we discuss this? Right. 0 degrees means 32, 100 means 200. Okay. So from here what you are going to get? Temperature in Celsius scale by 100 is equals to temperature in Fahrenheit minus 32 by 180. Right now 212 minus 32. Okay. So I can remove these two zeros. Okay. So 2 5s are 2 9s. Next, temperature in Celsius scale equals to, I can send this 5 here. So 5 by 9 into temperature in Fahrenheit minus 32. You are going to get something like this. If I ask Fahrenheit scale, see, if I give the data of temperature in Fahrenheit and converting into temperature degrees Celsius will be like this. If I give Celsius and asking you to do for Fahrenheit, then what I can do? See, I want this term right now. So means remaining all should come this side. So what I can make? So temperature in Celsius, here I have by 5 we have now, this 9 is there now, send this side into this goes to the numerator here, 9 by 5 equals to temperature in Fahrenheit minus 32 we have. Okay, send that 32 also this side. So temperature in Fahrenheit will be equals to, so minus means it becomes plus. So 9 by 5 temperature in Celsius plus 32 like this. Is this clear or not? Yes. Okay. Yeah. Okay. So if you want, you can write these. Okay. All these discussions are done. Okay. We have seen the units of volume, pressure and temperature. Okay. Then next. So tell me, answer these questions. Try to answer them. Yeah. Physical properties can be measured by without changing the composition of substance. Right now, next, units of pressure, Pascal. Okay. Next, Kelvin is unit of cubic meter is unit of volume. Okay. Next, chemical properties. Now we discussed previously about physical. Now chemical. So chemical property is a property or behavior of a substance when it undergoes a chemical change or a reaction. Okay. This is what you should focus more in chemistry. Now how a chemical is responding when it is treated with some other species, some other chemical substances, right now. Okay, so this is what examples like toxicity, how much effective it is. Like some compounds, if some compounds are consumed, what happens? It may become toxic, and few compounds are there, if you take that, that will be cure that person from the toxicity, right now. So we have two types, can be toxic and can be non-toxic, and can be used for clear this or cure from this toxicity. Okay, so there are many things to study under this chemistry now. Okay, so toxicity, next oxidation, reduction. Okay, next flammability. Flammability is also a property now here. Like some compounds have very high reactive nature, and few of them are having no reactive nature, right now. Okay, so next iron, for example, iron in the presence of moisture air becomes rust due to oxidation. So now iron converting into respect to iron oxide. So what is this process? Oxidation process. So we are, see, initially what I told, iron, now I am saying iron oxide. Okay, oxide means oxygen is added to this iron. Okay, what is this process? Addition of oxygen is considered as oxidation. Okay, yeah, we will discuss about all these things, okay, in the upcoming classes. Just have some clarity over what exactly happened. So density, units of density is density formula, mass by volume. Mass will be in kg, volume in so meter cube. Okay, kg per meter cube. So I can write kg by meter cube or kg into meter power minus 3. Okay, so if anything is there, something like this, see, like meter 1 by some m cube is there, so you can write this as m power minus 3. Is that clear? Okay, yeah. So this one, next. So now we'll have some view on this chemical reactions or chemical equations, what happens here exactly. So look at here. So chemical equation means what? It is a symbolic representation of a chemical reaction, which is also known as chemical equation. Okay, so for example, a reaction is taking place between these AB molecules. Okay, so to form some product, let us say C is a product. So now I am not giving complete formula of that, complete name of that like that molecules A and B molecule. Just I am using the symbols. Okay, for example, I am saying calcium carbonate. Here I am not writing calcium carbonate here. I am just using a symbolic representation of this calcium carbonate. What is the symbolic representation? Calcium. We have calcium element. So what is the symbol of calcium? Ca. Carbonate. Carbonate contains 1 carbon and 3 oxygen. So that is CO3, calcium carbonate. Okay, so decomposition of calcium carbonate. Upon heating this, heating symbol I am using something like delta. Okay, so delta represents heating. Okay, upon heating what happens? So this will undergoes decomposition, like calcium oxide plus CO2 gas is released here. Okay, so if you observe, I haven't given it in the their names, so I used their symbols. So these equation, is it balanced or not? Yes. See how many calcium atoms are there here? Here also oxygens, how many are there? 3. Here this is 1, this is 2, total 3. Carbons 1 and 1. Is that balanced or not? So left side, right side, LHS side, RHS side, always all the atoms should be balanced, same. See, a chemical reaction should always balanced. Okay, so you can say LHS side, RHS side, number of atoms should be same. Okay, that is what we are going to study, law of conservation of mass. Okay, so now I hope this is clear. Now try to tell me for these. I am just giving you a reaction like a name representation. Methane plus oxygen gives, upon combustion, gives carbon dioxide plus water. Okay, so now represent in a balanced reaction for this. CH4 for methane, O2 for oxygen, CO2 plus H2. Now what I am asking, a balanced equation. So look at carbons, 1, 1. Okay, next hydrogens, 2 only. So what I should do, less here now, how many less? 2. So I can multiply with 2 this equation, 4 hydrogens. Next, oxygens. I need to fix this number, how much? So look at here, we have 2 oxygens here, 2 oxygen atoms here, and here also 2 oxygen atoms. Total 4 oxygens. But here how many oxygen atoms are there? 2. So should be, what we should do? Multiply with the 2. So it becomes 4. Okay, this is a balanced equation. Yes or no? Yeah, like this. Okay, I hope you got some basic idea on this. Again, next, let us move forward. Yeah, so now Dalton's atomic theory. So what he says, look at here. So according to him, matter is made up of extremely small particles called atoms. Okay, so now what he says, all matter is made up of tiny indivisible particles called atom. It means atom is the smallest particle of a matter. Okay, okay, next, atoms are neither be created nor be destroyed in a reaction. So this is also very important point. Atoms neither be created nor be destroyed. During a chemical reaction, whatever the atoms present reactant side should present on the product side. Okay, so what you have seen here in this example, in this methane example or calcium oxide example, see here methane, atoms are, see in the methane, carbon hydrogen are combined here, but this side atoms are not in the same direction, like not like combined as in the reactant side. See, they are reorganized here. See, carbon is carbon is combined with oxygen here, hydrogen combined with oxygen, something like different compounds are there, but total number of atoms are same, reactant and product side. Number of carbons here and here are same, oxygens here and here are same. So I can say during a chemical reaction, atoms can neither be created nor be destroyed, but they can be reorganized. See, hydrogen atoms are reorganized. Yes or no? Reorganized means it is organized here with the carbon, but here this side it is organized with the oxygen. Is that clear what I am saying? Yes. Okay, let me move forward. Okay, atoms of a given element are identical in mass and chemical properties. For example, I am saying carbon element. So the atoms of this carbon element will be have same properties, like taking a drop of blood from your body and looking at its like details. Okay, like what group it is, whether it is healthy or not, all these things, something like atom of one element will be have same properties, whether physical, chemical properties will be same for a particular element's atom. Okay, see, atoms of given elements are identical in their mass, chemical properties, physical properties, all. Okay, next, atoms of different elements have different chemical properties and different masses. Now I can take carbon and nitrogen. They have carbon atom, nitrogen atom. They have different chemical properties, different mass number, like this now. So they are different. Okay. So these 2 points also clear. Next, atoms combine in a fixed whole number ratios to form compounds. Okay. So for example, in order to form CO2, we have fixed mass number of oxygen and carbon. So it will be 12 grams of carbon is required for reacting with 32 grams of oxygen. So what is the fixed ratio here we are going to get? See, like I can say 4 3s are 4 3s are 4 8s are. So what is the ratio of carbon and oxygen? 3:8 in carbon dioxide. Okay, So always in order to form carbon dioxide, carbon and oxygen ratio must be 3:8. Whatever the quantities you are taking, but that ratio must be 3:8. Is that clear? Okay, that will be fixed. Okay, next, relative, the relative number and kind of atoms are constant in a given compound. Okay, yeah, that is also like atoms are constant here. How many oxygen atoms? 2. Those are constant, they are saying. Okay, next. Laws of chemical combination. It is also important, very basic one. Okay, to explain the basis of chemical reactions involving atoms and molecules, this law of combinations are useful. So what they are? First one is law of conservation of mass. It is given by Anthony Levison. Okay, so now what he states? So what he states? The mass of the total mass of reactants and products should be same. The total mass of a reaction is conserved. Okay, so now see here, the total mass of reactant is same as that of total mass of products. It means, for example, A and B are combining to form some product 2C plus D, let us say. Now the total mass of reactant, see, in a given reaction, this side can be called as reactants. What is that? Reactants. And this side, arrow this side, products. So total mass of reactants are should be equals to mass of products formed. Total mass of reactants should be equals to total mass of products. Okay, like this. Okay, so here what are the reactants we have? Weight of A plus weight of B should be equals to weights of this product C plus weight of D. Okay, whether it is formed 2 times, 3 times, but total mass, whatever the mass here we are going to get, total that mass should be there this side. Okay, for example, here total mass is 20 grams. Product side also total mass should be 20 grams only. Okay, is that clear? Okay, next. So just try this question. Methane plus oxygen forms what? CO2 plus H2. Okay, now I am saying 16 or 8 grams of methane, 8 grams of methane and 16 grams of O2 are combined, then mass or weight of products formed. How much weight of product is formed? What is the mass of product formed? So nothing to get confused here. How much it is? So 20, 8 3s are 24. So just add 24. So 24 grams of product side should be also there. Then only we can say law of conservation of mass is verified here. So now first of all balance this given equation. Whether it is balanced? No. Okay, carbon 1, carbon 1. Oxygens, hydrogens 4 oxygens, everything is balanced. Now we have one methane, 2 O2. So methane mass, you know how to calculate mass number for a molecule? Okay, for example CH4 I have. What is the atomic number of carbon here? 6. Okay, so 6 now, so multiply it with 2. That will become what? Mass number. Okay, so 12 plus how many hydrogens are there? 4 into 1. I am taking 16. Why? So you should ask me, sir, you are taking here 1 carbon is there, its atomic number is 6 and multiplied with 2. So here 4 hydrogens are there, 4 into 2 you should take now. Why you are taking only 1? So here because carbon has 6 protons, 6 neutrons in the nucleus and 6 electrons outside. When I am saying mass number, that is given by neutrons plus protons. So 6 plus 6, 12. That's why I am taking 12 into 1 for carbon. 1 carbon is there. If it is 2, 12 into 2, 24 like that. Okay, hydrogens has only proton, there is no neutron in the hydrogen. So it means mass number becomes how much? 1 plus 0, 1. That's why I have taken 1 into 4. Is that clear? Why I have taken 16 here? Clear now? Yeah. So one I can write, or one molecule I can write as 16 atomic mass units, or 1 mole I can say 16 grams here I can say. And this is 2, oxygen atomic number is 8. For oxygen atom it is 16. For O2, 2 atoms are there. 16 into 2. So take here 32. Again for O2 it is 32. Again it is multiplied with 2. So 16 grams required, 64 grams. Okay. So now I have only 8 grams here, and this one I have 16 grams. Okay. So now when I have 16 grams of methane, I required 64 grams. Okay. So if I have 8 grams, see 16 is becoming 8, means what is happening here? Just I divided by 2, let us consider. So here also you should divide by 2, it should be 32. So in order to combine complete 8 grams now, in order to combine consume all these 8 grams, how many grams of O2 is required? 32 grams is required. But how many grams I have? 16 grams only I have. It means this is lesser than the requirement now. We require 32, but it is only 16. It means out of this 8 grams, only 4 grams will undergo combustion. Remaining 4 grams remains unreacted. It will remains unreacted. Out of 8 grams, 4 grams will remain unreacted, 4 grams will participate in the reaction. Okay. So therefore, so for 1 it is giving 1 mole. Okay. So for 1 mole it is 1 mole. Now here I am saying what, how much amount it is consumed? 4 grams is consumed here. Okay. So that 4 grams react with here how many grams? I just given you how many grams? 16 grams. Okay. So 4 grams plus 16. So total mass formed of CO2 plus water is how much now? That will be 4 plus 16. How many grams of CO2 plus water is formed? 20 grams. Okay. So 20 grams is formed. Then what about remaining? So what is the mass I have taken this side? 6 plus 24 grams I have taken. But how many grams of product formed? 20 grams. What about remaining 4 grams? That is methane remained unreacted. So total here I can say plus 4 grams of carbon is remained unreacted. So after taking that reaction crude, what we are going to get? We are going to get 20 grams of these products as well as 4 grams of carbon which is remained unreacted. Like this you should able to understand. Is that clear or not? Yes. Yeah. Sorry. Yeah, I hope it is clear now. I hope this blur is having some disturbance in the camera. Yes. So we'll fix it soon. Yeah. So I hope it is clear now. So let's move forward. We have, I hope you got this clearly what I have given here. Okay. So now about these calculations, once I covered mole concept, you will feel more clear about this concept. Okay. Next, law of constant composition or definite proportions. Law of constant composition or definite proportions. It means just see, this is given by what? Who? That is Joseph Proust in 1779. So what he is saying, a chemical compound always always consist of same elements combined together in a definite proportions by weight. For example, just now we discussed carbon oxygen will combine to form carbon dioxide always with a definite proportions of 12:32. So that is how much? 3:8. This ratio is fixed. Right now, in order to form carbon dioxide, the composition of carbon and oxygen is fixed in these ratios. From wherever it is forming, always should contain 3:8. Okay? So I hope this is also clear. Let us say water molecule formation. So what is its composition? Tell me. So 2:16. So mass ratio will be fixed as 1:8 like this. Is that clear or not? Yes. Okay. Next. So from whatever the source of water originating, whether it is tap water, whether it is some mineral water, or whether it is from river water, always that contains what? Fixed ratios of hydrogen oxygen mass. How much it is? 1:8. Okay? Yes. Next. We'll come back to this. So look at this question. Answer this fast. Law of conservation of mass is not applicable for radioactive isotopes. Okay, remember this. Why? Because during this radioactive reaction, some of the mass will be converted into energies. For example, you are seeing these nuclear weapons now. So in that, we are seeing some high amount of energy is released. How that energy is generated? Some of the mass of that particular substance we are taking, that will be converted into energy form. Okay, therefore if it is converted into energy form, so mass number will be decreased in a little bit. That is what you should remember. Okay, in other reaction, just write the reaction and try to balance it, you are going to get exact value. Okay, next. Law of constant composition, next one we have studied now, that fixed compositions is not valid. See, is not valid for compounds in which isotopes are concerned. It means isotopes are concerned means, for example, carbon has atomic number 6. Okay, so it means it has how many protons? 6 protons. Okay, but inside the nucleus we have something called neutrons. Right now these neutrons can be 6, sometimes it can be 7, and sometimes it can be 8. When it is 7, we are going to get a carbon with atomic number is 6 only, because always protons will remains same here. Okay, but number of neutrons are varying. So atomic number is same, but mass number will be varies here. Why it is varies? Because mass number is sum of neutrons plus protons. So what is the mass number here? It is 14. For this it is 13. For this it is 12. So these are called isotopes of carbons. So that is natural existence. It is existing like that. Okay. So now these are the mass numbers because varying their neutrons. So these are called what? Isotopes. So if we extract from the earth crust this carbon, we are going to get almost more than 99.9% of this carbon and very minute percentage of this C13 and very less percentage of this C14. Okay, out of this C12 is the major and stable isotope of carbon. Okay, due to difference in a number of neutron, that stability is also varies. Okay, so which is more stable? C12 isotope. Okay, now, so in this case, if you see, I have carbon dioxide. Carbon dioxide I have. What is the fixed ratio of masses? 3:8. right now, or I can say 12 is to 32. But if I consider this C14, what you are going to get? CO2 formed from C14, how you are going to get? 14 is to 32. 13, here it is 13 is to 32. Here you are going to get 12 is to 32. Out of this, which is satisfying this condition? Only C12. So this isotope case it is not considered. So that is what I have mentioned. Law of constant composition is not valid for compounds which isotopes are concerned. If isotopes are there, this is not valid. Only for stable species only it is considered, like the C12 like species. Okay. Next, one more thing is non-stoichiometric compounds. What do we mean by non-stoichiometric compounds? See, sometimes we have some compounds, something like metals. Let us say like titanium metal is there, something like transition metals are there, no? So they have metal surface area will be there. Okay. So on the surface area of metals there will be some defects. On the metal lattice we have some defects. So due to that some small holes are created. Those are called voids. What is that? Voids. So in that voids, some of the small elements like hydrogen gas or helium, like hydrogen gas or carbon gas will be accumulated. So that what it will be forming? Now titanium hydride is there. Some hydrogen gas is passed through this titanium metal. So now what happened? This gas, hydrogen gas may accumulate in that voids. So something like we are going to get something like, we don't know how much amount of oxygen gas that fits into that void. So that we are going to get something like titanium 0.559, something like this. There is no fixed ratio for like titanium to hydrogen. Okay. So these kind of compounds are called non-stoichiometric compounds. So in this case also constant composition is not valid. Okay. Two things are important here. One is non-stoichiometric compound, another one is, yeah. Next. So now what is an atom? Okay. So now I suggest, or we will start this session from the next class. Okay. So we will start this topic in the next session. Okay. If any doubts are there, you can ask me now. See, I just wanted to clear your basics only. Basics means from the scratch. So any doubt from the scratch you can ask. Should not feel scared or something like sir is discussing something which is very high or very low like that. So you can ask any doubt, whether it is scratch or top level, advanced, medium, anything you can ask if you have any doubts. Okay. If no doubts, I can wind up this. Okay.